Hello, and welcome to Sleepy Story Facts, a gentle sleep story for anyone who wants to fall asleep with calm thoughts and a quiet mind. Tonight, as you settle into your pillow and let your shoulders soften, we'll wander slowly through the most relaxing facts about life on Earth, noticing how living things don't just exist here, but quietly adapt and flourish in ways that feel almost like soft magic. Life that glimmers in the deep ocean like a distant lantern. Life that grips sun-baked stone in deserts that seem too dry for anything to endure. And life that floats invisibly in the air, sharing the same patient world with all of us. If you enjoy this bedtime story style of calming narration, you're always welcome to support the channel in whatever gentle way feels right another day. But for now, there is truly nothing to do, nowhere to go, and no problem to solve. Just breathe slowly, let your eyelids grow heavy, and allow these nighttime story facts to move at an unhurried pace, like waves folding onto shore. And as we begin, imagine the earliest chapters of life not in a bright, sunny pond, but far below the surface, where the ocean turns dark and quiet, and the water grows cold and still, except in a few strange places where the seafloor opens into hydrothermal vents, tall, chimney-like structures that release heated water and minerals from deep within Earth. It sounds harsh, yet the chemistry there is rich and active, with minerals that can help small building block molecules meet, combine, and linger in tiny natural pockets, almost like sheltered rooms carved into stone, where simple ingredients may have had enough time to become something more. Some scientists picture these mineral-lined spaces as early, protective workshops for life, places where fragile beginnings could form away from the roughness of the ancient surface. And even now, those vents remain busy with living communities that never rely on sunlight at all, drawing energy from the planet's own chemical breath, which makes it strangely comforting to think that our shared origin story could be rooted in darkness and depth, shaped by heat and pressure, and carried forward by patient time. And then, as the world turns through seasons, there are creatures that meet winter in a way that feels almost impossible. Imagine becoming so cold you turn stiff with ice, and yet, when warmth returns, you simply wake and continue. Some frogs, like the North American wood frog, can survive by letting much of their body freeze during deep winter, their heartbeat pausing and their circulation slowing to near stillness, while protective sugars in their tissues help guard delicate cells, acting like a natural antifreeze so ice crystals do less harm. When spring arrives, the thaw comes gently, and the frog revives, as if life itself has been calmly waiting in the wings. Certain insects and tiny invertebrates have their own versions of this winter patience, enduring temperatures that would end most living things, reminding us that life on Earth is not only resilient, but quietly creative, able to rest, to pause, and then to begin again when the moment is kind. And while we often think the sun is the leader of the living world, plants reaching for light, animals depending on plants, and everything following that bright rhythm, there are entire ecosystems that never receive a single ray. Far below the surface, where no dawn ever arrives, around those same deep-sea vents, you find pale, graceful communities of tube worms, crabs, and fish that move through black water, supported by bacteria that perform chemosynthesis, harvesting energy from chemicals such as hydrogen sulfide rising from the vent flow, building a food web without needing sunlight at all. In deep caves underground, other creatures live their whole lives without day or sky, sometimes losing their eyes over generations, their bodies instead leaning into touch, vibration, and scent to understand their world, as if darkness is not a lack, but simply a different kind of home. And drifting through all these ages, moving with a slow, unhurried pulse, jellyfish have been part of Earth's oceans for more than 500 million years, far older than dinosaurs, and older than many familiar forms of life, surviving extinctions that erased countless species, while their own design remained almost perfectly suited to the sea. They are simple and astonishing at once, mostly water, without bones, without a heart, without anything that resembles a human mind. Yet they glide with the currents, sometimes glowing softly as though lit from within, sometimes gathering in vast blooms that spread like living clouds. They can recover from injury, tolerate changing conditions, and continue their slow ocean drifting. And there's something deeply soothing in picturing a jellyfish moving through dark water, a quiet traveler from deep time, reminding us, without any hurry at all, that life has been finding gentle ways to continue for longer than we can easily imagine. Back in that long, dreamy view of deep time, it's quietly amazing to notice how a form as simple as a jellyfish can keep working, age after age, as if the ocean itself approved the design and never needed to change it much. And from that calm thought, we can drift into another gentle wonder life that doesn't rely on leaves or prey or sunshine, but instead makes a living from the bare bones of the planet. Because some microscopic organisms can eat rocks in their own patient way, using minerals the way other creatures use food. These microbes, often described as lithotrophs, draw energy by moving electrons from substances like iron or sulfur, and sometimes even more unusual elements, turning stone chemistry into a slow-burning fuel far beneath the surface, where light never reaches, and where fallen plants and animals don't easily arrive. Whole communities can persist on this mineral-based lifestyle, quietly thriving in cracks and pores of the earth, like unseen caretakers of the underground. It's easy to see why researchers sometimes imagine them as a hint of what alien life could be like: simple, sturdy, and not dependent on green forests or bright skies, because they can even reshape the chemistry around them, gradually changing the minerals they touch. And over immense spans of time, these tiny lives may have helped nudge Earth's environment into what it is today. If you want a soothing image to carry toward sleep, picture those invisible miners in the dark, unhurried and steady, drawing gentle energy from stone, and doing well where almost nothing else could. And as we continue this relaxing story about life on Earth, time begins to stretch in another direction too, because some living beings have been here so long that old barely fits as a word. Beneath cold northern waters, certain seagrass meadows can be clonal, spreading year after year as the same genetic individual expands, with some colonies estimated to be more than 10,000 years old. quietly weaving themselves along the seafloor like a soft green quilt. On land, there are forests that are also, in a sense, a single organism, such as the famous quaking aspen colony called Pando, where thousands of tree trunks rise like separate individuals. Yet, all are connected through one shared root system, the whole grove renewing itself as older stems fade and newer ones take their place. These long-lived lives have outlasted countless generations of animals and humans, witnessing climates shift and seasons repeat until the pattern becomes almost hypnotic. And they gently remind us that longevity in nature is often less about one body holding on forever and more about continuity. Life persisting by calmly replacing parts of itself again and again, like a slow breath that never quite ends. Trees, which can seem still and solitary from a distance, sometimes hold this quiet strategy as a secret strength, because branches that rest against the ground may take root, and new trunks can rise nearby, allowing groves of willows, poplars, and other species to spread as genetically identical families, not through hurry, but through patient, persistent growth. In that way, a forest can be both mortal and enduring at once, continuously renewing, like a gentle bedtime story that keeps going even as each line softly dissolves into the next. And if you enjoy thinking about hidden worlds, there is a giant that many people would never notice unless they were told. Deep in the Blue Mountains of Oregon, an enormous fungus lives mostly out of sight, with only occasional mushrooms appearing above ground like small signs on the surface of something vast. Beneath the soil, a connected web called mycelium stretches across nearly 10 square kilometers, an underground network that can be thousands of years old and unimaginably heavy, slowly moving through roots and wood, recycling the forest from within, so that what looks like many separate patches is, in truth, one sprawling organism quietly occupying its territory. And finally, as the night grows calmer, it can be comforting to bring these wonders closer to home, because you are not only one life, but many lives living together. Inside and on your body exists a whole community of microscopic companions, bacteria, and other tiny organisms that scientists call the microbiome. And while the numbers are complex, the gentle truth is simple. You are an ecosystem with microbial partners that help with digestion, train the immune system, and influence how the body functions in subtle ways, while others simply live alongside you in peaceful balance. When you let that idea settle, it can feel strangely reassuring. Life is rarely solitary. And even as you lie quietly in bed, breathing in the dark, there is a calm, living chorus within you, keeping its soft rhythms, helping you rest, helping you continue. As you rest here in the quiet, it can feel soothing to remember that even our own bodies are not a single, isolated thing, but a gentle web of life working together. Countless tiny residents sharing one home, balancing and cooperating in ways we rarely have to think about. And from that close-to-home wonder, we can drift outward to a creature so small it's easy to overlook, and yet so tough it has become famous for endurance. The tardigrade, sometimes nicknamed a water bear, a little being with 8 stubby legs and a softly wrinkled shape, usually smaller than a millimeter, like a living speck with a a surprisingly sturdy spirit when its world becomes too dry or too cold, when radiation rises or conditions turn harsh. It can slip into a deep pause called cryptobiosis, drying itself down until it's almost weightless and still, as if life has been folded carefully away for safekeeping. In that state, tardigrades have survived extremes that would end most organisms: intense cold and heat, heavy radiation, and even the airless vacuum of space. Then, with the simple return of water, they can slowly awaken again, as if the body remembered exactly how to be alive. Part of this ability comes from protective molecules, including special proteins and sugars that help stabilize delicate structures inside their cells, guarding DNA and membranes so they can endure the long wait. It's a calm, bedtime story kind of thought, that life can sometimes become almost nothing and still remain ready to continue when conditions soften. And it also leaves a quiet, open question drifting in the mind. If Earth can produce a creature that resilient, what other hardy forms might exist on distant worlds, waiting in their own silence? And while we're already floating in the ocean's hidden rules, there is another gentle surprise beneath the waves. Some fish do not treat sex as something fixed for life, but as something the body can adjust when the group needs it, as if the sea values flexibility over certainty. In clownfish communities, for example, the largest and most dominant individual becomes female, while the others remain male. And if the female disappears, the next largest male gradually transforms, taking her place so the small society can keep going. In other species, such as wrasses and groupers, the direction of change can vary, with individuals shifting from one sex to the other, depending on social balance and the best chance for reproduction. These changes are not cosmetic. They involve deep biological transformations, with hormone levels reshaping, reproductive organs reorganizing, and behavior adapting over time. A slow rewrite of the body's own story in service of continuity. And as you listen, perhaps growing sleepier, it can be comforting to let that idea soften any rigid edges in the mind, because nature often survives not by forcing one pattern everywhere, but by allowing many patterns to exist. And then, like a quiet creature from a dream, there is the axolotl, an amphibian with feathery external gills and a calm, almost smiling face, sometimes called the Mexican walking fish, even though it's really a salamander. And its greatest wonder is renewal, where humans often heal with scars. Axolotls can rebuild, regrowing limbs, repairing spinal cords, restoring parts of the heart, and even regenerating sections of brain tissue with remarkable accuracy. When injured, cells near the wound can return to a more flexible state, then patiently rebuild what's missing, as if the body holds an internal blueprint and follows it step by step, not rushed, not dramatic, just steady and precise. Scientists study this ability with hope, imagining a future where understanding such regeneration might help humans repair damage that currently seems permanent. And in the meantime, the axolotl simply lives its life in cool waters, carrying this quiet talent the way a tree carries the ability to sprout new leaves. And speaking of patience, winter teaches some frogs an art that feels made for a calming nighttime story. Stillness so complete it looks like sleep itself, because certain frogs can spend months without breathing in the usual way, settling under mud or tucked beneath leaves, their bodies slowing into a low, careful mode. Some can remain underwater for long periods, taking in oxygen through their skin, while their metabolism drops so far that the need for air becomes faint. Almost like a whisper, they wait through the cold season without hurry, and when warmth finally returns, they rise again and resume their simple lives. A reminder that survival is sometimes less about constant effort and more about knowing when to be quiet, when to pause, and when to begin again. And then, in contrast to all this softness, the ocean also hides a tiny burst of astonishing power in the pistol shrimp, a small creature with a specialized claw that snaps shut so fast it shoots a jet of water and forms a low-pressure bubble. And when that bubble collapses, it releases a sharp shock wave that can stun prey for a fleeting instant. The collapse can create extreme heat and even a brief flash of light. And when many pistol shrimp live together, divers sometimes describe the sound as a gentle crackling beneath the sea, like distant firelight made audible. It's almost unbelievable that something only a few centimeters long can create a force that echoes the physics of far larger events. And yet, even this can be held gently in the mind as you drift toward deep sleep. Earth is full of quiet surprises, tucked into small corners, waiting to be noticed. And now, with the night settling in around us, we can begin to wonder about creatures of the sky as well, because there are birds that travel across continents with a calm certainty, and somehow, through mechanisms we're still piecing together, they can sense the planet itself as a guide, as if Earth offers them a subtle map written into its magnetic field. Still resting in the soft darkness of our bedtime story, we can stay with that image of birds crossing enormous distances and gently unfold the hidden tool that helps many of them, a real ability to sense Earth's magnetic field, a sense often called magnetoreception, like a quiet inner compass that never needs batteries and never asks for directions. Scientists think this may involve tiny magnetic particles within the body, or special light-sensitive proteins in the eyes that respond to magnetism. And some researchers even wonder if certain birds experience the magnetic field as faint visual cues, subtle patterns layered over the world, guiding them when the sky looks empty and the landscape offers few clues. This silent map helps animals travel with calm confidence, allowing Arctic terns to migrate from one end of the planet to the other, and helping pigeons find their way home, even when released far from familiar streets and rooftops. To us, magnetism is mostly a concept, something we learn about and measure. But for them, it can be as natural as sensing up from down, an invisible set of lines written into the air that quietly points the way. And speaking of long journeys that feel almost like living poetry, monarch butterflies perform a migration so gentle and astonishing that it barely seems possible. Each autumn, their delicate wings, thin as petals, carry them from Canada and the United States toward the mountain forests of central Mexico, a trip that can span thousands of kilometers. What makes it even more dreamlike is that no single butterfly completes the full round trip, because the the journey is shared across generations, with new monarchs continuing a path their ancestors began months earlier, so that by the time monarchs return north in spring, they may be the great-grandchildren of those that first set out, somehow guided by instincts we're still learning to explain. They locate the same wintering forests year after year, sometimes settling in the very same groves. And to imagine trees heavy with orange and black wings is to imagine a forest wearing a moving cloak, a slow, shimmering gathering that seems designed to calm the mind. And then, drifting back beneath the surface of the sea, we meet the octopus, one of Earth's most unusual and quietly brilliant animals, whose body is built with surprising elegance. Instead of one heart, it has three, with two sending blood through the gills, and one pushing it through the rest of the body. And its blood is not red like ours, but blue, because it relies on a copper-based molecule to carry oxygen, a setup that can work well in colder, lower oxygen waters. And the octopus's strangeness continues in gentle waves, as it can compress itself through narrow gaps that seem far too small, shift its skin color and texture as easily as changing clothes, and solve problems with an intelligence that feels almost like meeting a visitor from another world, reminding us that life on Earth doesn't follow one single template, but experiments patiently in many directions. And if you'd like to keep your attention softly anchored as you relax, you can turn to the watchful world of crows, birds known for remarkable memory and reasoning, including a talent that feels surprisingly personal. They can recognize individual human faces. Studies suggest they may remember someone who threatened them and respond again, even years later. And they can also recognize people who treat them well, sometimes lingering nearby with a calmer presence. Some stories even describe crows leaving small objects, shiny bits, pebbles, little treasures, near places where they've been fed, not as proof of anything magical, but as a hint of complex social behavior and a mind that notices, learns, and chooses. When a crow tilts its head and studies you, it can feel like being observed in return, as if a quiet judgment is being formed behind those dark, reflective eyes. And in the same soothing spirit of social connection, dolphins offer another gentle wonder, because they live in close communities where communication matters. And many dolphins develop their own unique signature whistles, distinct sounds that function much like names. Other dolphins can repeat these whistles to get an individual's attention, and dolphins can recognize their own name, even when another dolphin produces it, suggesting a kind of identity and relationship building that runs deep beneath the surface. It's a peaceful image, a pod moving through sunlit water, calling to one another in a chorus of whistles that carry through the sea like soft bells. And finally, we come to the quiet sensitivity of elephants, giant animals with an equally giant awareness of their surroundings, able to detect distant storms from remarkably far away, sometimes hundreds of kilometers, likely by sensing low-frequency rumbles below human hearing and subtle vibrations traveling through the ground. This early warning can help them begin slow, steady journeys toward water or safer shelter, long before the first raindrop arrives. And as you listen to this relaxing story and feel yourself sinking toward deep sleep, it can be comforting to know that across Earth, so many creatures are tuned to signals we don't even notice. Maps in the air, names in the water, and weather whispers traveling through the ground. As we stay in this calm nighttime story, you can imagine the land itself breathing softly, and elephants listening to it, because beyond sensing distant storms, elephants also use very low, rumbling calls to communicate, sounds so deep that much of the message can travel far across open ground, as if the landscape becomes part of the conversation. For such enormous animals, their awareness can feel finely tuned, responding not just to what they see, but to vibrations and distant signals. And to stand near an elephant is to stand near a creature that seems quietly connected to earth and sky, feeling the planet's mood in ways we can barely notice. And then we drift from land into the dim, wide ocean again, where humpback whales turn water into music, singing long sequences of moans and patterned phrases that can travel for hundreds of kilometers through the sea, carrying on and on as a whale moves slowly, sometimes repeating the same themes for hours like a lullaby with a deep, rolling rhythm. What makes this even more fascinating is that the song is not fixed, because over months and years, whale populations gradually change their shared melodies, adding new phrases, letting old ones fade, and spreading these updates like cultural waves across regions, so that a tune from one area can slowly influence another. And occasionally whole groups seem to adopt a new version with surprising speed. Scientists still debate the purpose: courtship, communication, social bonding, or something that feels almost like art. But whatever the reason, the ocean becomes a living concert hall, always evolving, always softly alive. And from the sea's music, we rise into twilight, that gentle in-between time when the sky looks simple to us, but is filled with subtle information. Because as sunlight scatters through the atmosphere, it forms polarized patterns, faint bands, and angles that human eyes don't read. Yet some animals can. Certain bats, skilled travelers of the night, appear able to sense these polarized cues to orient themselves, using dusk like a quiet compass. And when this sky guidance combines with echolocation, their navigation becomes both wide and precise, letting them not only weave between trees, but also migrate over long distances with steady confidence. It's a soothing thought to imagine seeing the evening sky not just as fading color, but as gentle guiding lines, like a soft map drawn in light. And then, as your breathing slows and your mind grows heavier, we can turn to a creature that challenges what we think thinking must look like. Because slime molds, neither animal nor plant nor fungus, can behave in surprisingly clever ways without any brain at all, spreading as a creeping, living network that extends delicate strands outward, testing the world for food in simple experiments. When placed in mazes with nourishment at certain exits, slime molds gradually explore corridors, withdraw from unhelpful dead ends, and strengthen the most efficient route, eventually tracing a path that looks like a solution, as though the organism is quietly learning the shape of the maze. Researchers have even observed behaviors that resemble a kind of primitive memory, where the slime mold adjusts based on repeating patterns, suggesting that problem solving can emerge from the collective behavior of cells, not only from neurons. It's a gentle reminder in this relaxing story that intelligence may be less about having a certain shape and more about how life responds to the world. And beneath your feet, hidden in soil and roots, there is another calm wonder of cooperation. Because long before humans practiced agriculture, certain ants had already become farmers. Leafcutter ants, for instance, travel in steady lines, cutting small pieces of leaves and carrying them back underground, not to eat the leaves directly, but to prepare them as compost for a fungus they cultivate in humid chambers. That fungus becomes their main food. And over millions of years, the partnership has grown so complete that the ants depend on the fungus, and the fungus depends on the ants, a shared life where each supports the other. Even more quietly impressive, some leafcutter ants also host helpful bacteria on their bodies that produce natural antibiotic compounds, protecting their fungal gardens from competing molds, like a built-in crop defense system. And these ant farms can scale into something like a living city, with a single colony reaching into the millions, spreading through networks of tunnels and rooms that can extend for many meters, organized into spaces for raising young, tending fungus, and sheltering the queen, who may live for around 20 years, laying eggs that keep the society flowing. The colony's coordination happens through scent signals, invisible trails of pheromones that guide workers like soft instructions in the dark. And when you picture it gently, it's almost like an underground bedtime world of quiet industry. Green fragments carried like little flags, gardens tended patiently, and life continuing in steady, peaceful rhythms that can help your own thoughts slow down, settle, and drift toward deep sleep as your body relaxes deeper into bed. It can be soothing to picture those enormous leafcutter colonies as scientists see them, mapped out like living cities, with routes, specialized roles, tidy resource flow, and even careful ways of moving waste away from the most important chambers, all managed without blueprints or meetings. Because the builders are tiny workers guided by simple instincts and chemical signals, and yet together they create organization on a scale that feels almost human. It's a humbling thought that under a quiet patch of ground, creatures no bigger than a fingernail can maintain a society that functions smoothly, moment after moment, like a calm machine made of life. And from those underground streets, we can drift to another masterpiece of insect architecture. Because in the warm savannas of Africa and Australia, termite mounds rise from the earth like natural towers, sometimes reaching heights of more than 6 meters, built grain by grain from soil and saliva into sturdy, sculpted forms. Inside, millions of termites live and work, often tending fungal gardens for food. But the most relaxing wonder to imagine is the way these mounds keep their inner world steady, even when the outside swings between intense daytime heat and cool nights. Because the structure functions like a breathing system, with vents, porous walls, and chimney-like channels that encourage air circulation and help regulate temperature and moisture. Termites constantly adjust their home, subtly widening or narrowing passageways as conditions change, as if the mound is always fine-tuning its own lungs. And this natural air conditioning has even inspired human designers who look for gentle, low-energy ways to cool buildings. You might imagine standing beside one at dusk, feeling the quiet presence of a towering clay skyscraper that seems almost alive, sheltering a hidden civilization in calm, steady balance. And then, continuing our relaxing story facts, we sink back into the deep ocean where sunlight cannot reach, a place that might sound empty, but is, in truth, full of its own soft illumination. Because many deep-sea creatures create bioluminescence, cool blues and greens, and sometimes rarer shades, turning darkness into a slow, underwater constellation. Tiny drifting organisms can sparkle like suspended stars, while certain fish carry glowing lures that sway gently in front of their mouths. And jellyfish can pulse with luminous patterns that look like quiet neon, sometimes flashing to confuse a predator and slip away. In these depths, light becomes a multi-purpose language used to hunt, to hide, to find mates, and to signal through the black water, sometimes glowing steadily, sometimes appearing in brief flickers that feel like distant signals across a night sea. For humans sailing long ago, a glowing ocean could stir awe and uncertainty. But for the animals who live there, this radiance is simply part of daily life, a calm tool for survival in a world where darkness is normal. And if you'd like a gentler light closer to the surface, you can imagine humid summer nights in certain forests where fireflies transform the air into a slow, breathing display. Because, while their flashes may begin scattered, in some places, whole groups synchronize over time, each insect adjusting its rhythm until the pattern spreads and thousands of tiny lanterns blink together. Like the heartbeat of the woods, scientists think this coordination can help them find mates. But whatever the reason, it's an image that can soften the mind, waves of warm light rising and falling through leaves, as if the forest itself is exhaling. And beneath the waves again, there are squid, masters of disguise, with skin built for quick, intricate change cells that expand and contract to shift color, layers that reflect light like polished metal, and structures that scatter brightness in subtle ways, allowing patterns to ripple across their bodies in an instant. Some species go even further, becoming nearly invisible by bending and scattering light, so their outline melts into the surrounding water, while others turn translucent, their forms fading until they look like moving glass. In the open sea, where hiding places are scarce, this vanishing act becomes both shield and strategy, letting a squid approach prey quietly, like a gentle ghost of the ocean. And even sharks, those ancient travelers of the deep, sometimes carry their own quiet glow, because certain species known as lantern sharks have light-producing organs that shine softly along the underside, often in greenish or bluish tones, helping them blend with faint downwelling light so predators below see only darkness, a kind of camouflage made from illumination itself. Other glowing sharks may use light to signal to one another in the dim twilight zone of the sea, their bodies marked with tiny photophores that resemble scattered stars. And if you let the image linger as you drift toward deep sleep, you might picture the ocean as a vast night sky turned upside down, jellyfish like floating moons, plankton like stardust, and slow-moving sharks gliding with a hush of living light. As you continue to sink into this gentle bedtime story, you can hold onto the calming idea that the deep ocean is not an empty blackness at all, but a quiet stage where living lights glow and fade, where even predators may carry their own lanterns, and where survival can look like soft illumination drifting through water. And in that same cold, dim world, one of Earth's most mysterious, long-lived animals moves with unhurried patience: the Greenland shark, a massive, slow-gliding creature of the North Atlantic that often travels through icy depths as though time barely touches it. Many Greenland sharks live with small parasitic worms attached near their eyes, sometimes leaving them nearly blind. And yet, they continue on, sensing their world in other ways, calm and steady by studying the chemistry of their tissues. Scientists have estimated that some individuals have lived for more than 400 years, making them the longest-lived vertebrates we know, which means a single shark might have been swimming quietly before many famous chapters of human history even began. They grow at an almost sleepy pace, sometimes less than a centimeter a year, and may not reach maturity until well over a century old. And something about the cold water and slow metabolism seems to protect them from the fast, or that shortens so many lives. It's a soothing thought, really, to imagine a creature moving through dark water for centuries, like a living hourglass turned upside down, reminding us that the flow of time can feel completely different depending on the body that carries it. And while that shark teaches us about long life, certain smaller fish show us a different kind of endurance: how to survive when oxygen disappears. Because in winter, some ponds and lakes become sealed under ice, and the water can lose most of its oxygen as months pass. For most animals, that would mean a quick end. Yet goldfish and their hardy relatives, such as crucian carp, can endure for weeks in oxygen-poor water by shifting their metabolism in an unusual way. Instead of building up lactic acid the way human muscles do when starved of oxygen, they convert those byproducts into ethanol, basically alcohol, and release it into the water, reducing the internal damage that would otherwise accumulate. It's a strange, almost dreamlike strategy, like turning stress into something that can simply drift away, allowing these fish to wait out the long, suffocating stillness until conditions improve. And another ancient survivor takes patience even further: the lungfish, a creature sometimes called a living fossil because it carries both gills and a lung-like way of breathing, giving it options when water becomes unreliable, when drought arrives, and rivers shrink into cracked mud. The lungfish doesn't struggle against the inevitable. Instead, it burrows down, secreting a thick mucus that dries into a protective cocoon around its body. And inside that shelter, it slows its metabolism to a whisper, taking tiny breaths of air, barely spending energy, as if choosing to sleep through hardship rather than fight it. This state, known as estivation, can last for months, and in some cases even years, until rain returns and water rises again. And then the lungfish emerges, steady and alive, as though it has simply been waiting for the world to soften. It's a beautiful lesson for a relaxing story to fall asleep to. Sometimes persistence looks like rest, like trusting that change will come in its own time. And then, drifting along ocean currents in a different kind of mystery, there are eels, whose life cycle puzzled humans for centuries because their breeding grounds seemed to vanish from observation. Today, we understand that European and American eels spend much of their lives growing in rivers and lakes, sometimes for decades. And then, when the moment arrives, they begin an extraordinary migration across thousands of kilometers to the Sargasso Sea, a region of the Atlantic associated with drifting seaweed and open water secrecy. There they spawn and die, and their young, tiny, transparent larvae, shaped in a way that can resemble thin leaves, float back on currents, slowly transforming as they travel, eventually reaching the freshwater homes their parents will never see again. Even now, this journey remains difficult for scientists to witness directly, which leaves the eel's story wrapped in a soft veil of mystery. Like a chapter, the ocean keeps mostly to itself and closer to coral reefs. There is a smaller nighttime ritual that feels tender in its own way. Because when darkness settles, some parrotfish prepare for sleep by making a kind of protective blanket, secreting mucus that forms a clear cocoon around their bodies. This shimmering bubble can help hide their scent from predators, such as moray eels, and may reduce parasites, turning sleep into a quiet act of clever protection. By morning, the fish breaks free and returns to daytime life, nibbling and crunching with its beak-like mouth, activities that over time help create fine sand that gathers into tropical beaches. So each night the cocoon returns, and each morning it dissolves, a calm cycle of rest and renewal. And as your own breath becomes slower and softer, we can let the reef fade gently into the background, preparing to drift into the next wonder waiting just ahead in our nighttime story. The surprising way seahorses bring new life into the world. Here in the gentle flow of our sleep story, we can return to the quiet ocean and meet the seahorse, a creature that seems designed to soften our assumptions. Because in seahorse life, the usual pattern of parenting is beautifully rearranged. After a slow courtship of small dances and careful, floating gestures, the female places her eggs into a special pouch on the male's body. And there, he fertilizes them and becomes the caretaker, providing a protected space where the developing young receive oxygen and nourishment as they grow. After some time has passed, weeks of calm waiting, he begins a kind of labor, releasing tiny, fully formed seahorses into the water, miniature copies that drift away into their own lives. And this arrangement allows the female to produce more eggs, while the male takes on the role of carrying and nurturing, a reminder that nature doesn't assign one single script to family, and that normal can mean many things depending on the species. And if you let the image linger, it's both surreal and quietly moving, new life arriving in a soft burst of tiny shapes, while the parent who carried them simply returns to the gentle rhythm of the sea. From that ocean cradle, we can glide up to a still pond where another kind of wonder happens right on the surface. Because some insects truly do seem to walk on water, and water striders, with their long, slender legs, move across ponds and streams as if skating on glass. Their secret is a calm piece of physics. Their legs are covered in fine, water-repelling hairs that trap a thin layer of air, helping them avoid breaking the surface tension. So each step presses down into a small dimple, and pushes back like a tiny trampoline. Sometimes many striders gather at once, sliding in smooth patterns across the mirrored water, living in a world that exists at the boundary between air and liquid, safe from many predators below and close to small bits of food above. And watching them can feel like seeing a quiet miracle that is, for them, simply everyday life refined over millions of years. And then, as this bedtime story continues, we circle back to the nearly indestructible tardigrade, also called a water bear, because beyond surviving extremes like vacuum exposure, tardigrades can also withstand radiation doses far beyond what humans can tolerate, in part because they produce protective molecules that help shield DNA, and because they can enter that deep paused state, cryptobiosis, where they dry out, slow their metabolism almost to nothing, and become extraordinarily resistant to damage. Later, with the return of water, they can revive, as if the body had been safely stored until the world became gentle again. And researchers study these creatures with curiosity, because understanding their resilience might one day influence how we think about radiation protection, medicine, or long journeys through space. It's a comforting message for anyone trying to fall asleep. Strength isn't always loud, and it isn't always large. Sometimes it's quiet endurance, the ability to wait and then continue. And in some of Earth's harshest landscapes, life uses a similarly quiet strategy by hiding in plain sight. Because certain algae survive inside rocks, living within porous, translucent mineral layers that filter the intense sun and protect against drying winds. These endolithic organisms make do with the faint light that penetrates stone and the rare moisture that seeps through microscopic cracks. And they've been found in places like Antarctica's dry valleys and the Atacama Desert, environments so extreme that scientists sometimes use them to imagine conditions on Mars. It's a gentle but powerful idea that life doesn't always need comfort or abundance, only a small opening, a tiny possibility, a place to persist. And speaking of cooperation, lichens offer one of the calmest examples of partnership on Earth, because what looks like a simple crust on rock or a soft patch on tree bark is often a blended living system, a fungus joined with algae, or sometimes cyanobacteria, each providing what the other lacks, with the fungus offering structure, protection, and access to minerals, while the photosynthetic partner captures energy from light. Together, they can colonize bare stone, rooftops, icy ground, and other places that seem too empty to support life, slowly helping break down surfaces and preparing the way for other organisms. And some lichens may persist for very long spans of time, quietly surviving heat, cold, and dryness that would defeat many plants. In a relaxing story like this, lichens feel like a small lesson written into the landscape. Survival is not always about winning. Sometimes it's about joining, sharing, and becoming something new together. And as the night continues to deepen, the next wonder waiting ahead is even stranger in its own calm way. Bacteria that can breathe without oxygen at all, using metals instead, as if life has more ways to keep going than we ever expected. As the night grows quieter and your thoughts slow. We can follow life into places where sunlight never arrives: deep mud, dark caves, and underground aquifers, where some bacteria carry on without oxygen by using metals as part of their breathing chemistry, treating elements like iron or manganese, and in some cases, even uranium, as substitutes in the final steps of metabolism. In a sense, these microbes exhale changed forms of these metals, leaving rust-like films on rocks or shifting minerals into new chemical states. And over long periods, they can gently reshape their surroundings, as if the underground world is being slowly repainted by invisible hands. Their existence also hints at Earth's ancient eras, when oxygen in the atmosphere was scarce, and different chemical pathways kept life moving forward. And it quietly expands our imagination of what might be possible on other planets where breathable oxygen may never have been available. To picture organisms that can breathe metal is to realize how flexible life can be, turning what looks inert into a usable flow of energy, and finding persistence in the most unlikely places. And from those deep mineral shadows, we can come up to a very modern material that humans spread almost everywhere: plastic, a substance designed to last, drifting through oceans, settling into soils, and resisting decay for a long, long time. Yet, even plastic has begun to enter the living world's slow cycle, because researchers have found certain microbes that can break down specific plastics and use them as a resource. One well-known example is a bacterium called Ideonella sacchaensis, which produces enzymes capable of dismantling PET, the plastic used in many bottles and packages. And some fungi have also shown plastic digesting potential in laboratory conditions. These processes are not instant, and they are not a perfect solution, but the very fact they exist is quietly astonishing. Within only a few decades, living systems have begun adapting to a material that never existed in nature before, which can feel sobering when you think about the scale of human impact, yet also strangely calming in the sense that life keeps experimenting, always trying to fit the world it is given. And if you'd like to rest with a gentler image, we can step into a forest at night where the air is cool and the ground smells faintly of soil and leaves. And beneath your feet, a hidden network is at work, fine threads of fungi weaving through the earth, linking tree roots into shared systems that can move nutrients from one place to another. Through these fungal connections, trees may exchange resources like sugars and minerals, and they can also pass along chemical signals, subtle messages that help a forest respond to stress, such as insects or drought. Some research describes larger, older trees as important hubs in these networks, sometimes called mother trees, because they can support younger seedlings by sharing resources through the underground web. And this whole idea has earned the nickname Wood Wide Web, a soft phrase for something that is, in reality, ancient and complex. Above ground, trees seem separate, like solitary pillars. But below ground, they can be part of a community. And knowing this can make a nighttime walk through the woods feel different, as if every trunk is quietly connected by threads you cannot see. And plants communicate in another way too, not through roots, but through the air. Because when some plants are being eaten, leaves chewed by hungry insects, They can release volatile chemical compounds that drift outward like faint, invisible perfume. Nearby plants, especially of the same species, may detect these signals and begin preparing defenses, making leaves taste more bitter, strengthening tissues, or even attracting predators that feed on the insects, turning the air into a gentle warning system that most human senses never notice. It's easy to think of plants as passive, but their stillness hides active strategies, and their language is written in chemistry and scent. And then there is the Venus flytrap, one of the most famous plant hunters, which shows a surprisingly careful kind of decision-making. Inside each trap are sensitive trigger hairs, and a single touch is often not enough to close it. But if a second touch follows within roughly 20 seconds, the trap snaps shut, as if the plant is quietly counting to confirm a living meal rather than wasting energy on a falling raindrop or a stray bit of debris. Once closed, continued movement inside stimulates the plant to release digestive enzymes, slowly breaking the insect down into nutrients. A patient process that turns stillness into strategy. And even the idea of memory, something we usually reserve for animals, appears in subtle form in certain plants. Because in experiments with the sensitive plant Mimosa pudica, which folds its leaves when touched, researchers have repeatedly given it a harmless disturbance. And over time, the plant reduced its defensive response, as if it learned the event was not dangerous. Remarkably, after time had passed, it could still behave differently toward the harmless stimulus while responding to new ones, suggesting a kind of biological remembering without a brain, a calm adjustment based on experience. And as you continue listening to this relaxing story, letting it carry you toward deep sleep, you can allow these quiet plant and microbe wonders to soften your thoughts, reminding you that life communicates, adapts, and persists in ways that are often invisible, but always gently present. As you lie here, letting this relaxing story carry you gently along, it helps to remember that the kind of memory some plants show doesn't rely on neurons or thoughts the way we experience them, but on quiet biochemical shifts inside cells, small changes in proteins, signals, and internal chemistry that influence how the plant responds the next time something happens. In that way, even without a brain, an organism can store a trace of the past and behave differently in the future, which is a soothing reminder that awareness and adaptation can take many forms, and that rooted life is not lifeless or unaware, just tuned to the world in its own slow language. And from this calm idea of learning without thinking, we can move to a plant that seems to embody energetic renewal. Bamboo, one of the fastest growing plants on Earth, which in ideal conditions can extend at an astonishing rate, close to a meter in a single day for certain species, so fast that people sometimes claim they can almost watch it rising if they're patient enough. Its hollow, segmented stems help water and nutrients move upward efficiently, feeding that rapid upward push. And across history, bamboo has supported human life as well, becoming food, shelter, tools, woven surfaces, and even musical instruments, while its speed of regrowth makes it feel like a symbol of resilience, harvested, and yet able to return again within a season. offering a living lesson of strength through flexibility and power through patient design. And then, drifting into the humid stillness of rainforests, there is a bloom that feels like it belongs in a dream because it is so large and rare. The Titan arum, sometimes called the corpse flower, a plant from Sumatra that occasionally produces a towering flowering structure that can rise over 3 meters tall, like a single dramatic spire lifting above the forest understory. When it opens, the interior can appear deep and richly colored, and it releases a strong odor reminiscent of rotting flesh, not as cruelty, but as strategy, because that scent attracts carrion beetles and flies, pollinators that are drawn to the promise of decay. So, as they explore the bloom, they carry pollen and help the plant reproduce. When a Titan arum flowers in a botanical garden, people often gather because the event is brief and uncommon. A short window when something enormous and strange appears and then fades again. And in that fleeting intensity, there's a soft reminder that life can be bold and temporary at the same time. And on a smaller, more delicate scale, some orchids use deception rather than size, evolving petals that resemble the shape of female insects and releasing fragrances that mimic pheromones. So a male insect is lured in by an irresistible false signal and attempts to mate with the flower, brushing against pollen in the process. When the insect moves on, still driven by instinct, it carries that pollen to another orchid and accidentally completes the plant's reproduction. A quiet trick that shows how survival can depend on subtle persuasion rather than force. And if the idea of scent as a message feels vivid, seeds offer a different kind of wonder, silence, and waiting. Because a seed is like a small time capsule, carrying a complete blueprint for a future plant inside a protective shell, able to slow its metabolism to nearly nothing and remain dormant until conditions finally become kind. Some seeds can endure far beyond a normal lifespan, and there are famous cases where ancient seeds have been revived, such as a flowering plant grown from material recovered from Siberian permafrost, reported to be around 30,000 years old, and a date palm seed from the Judean desert, about 2,000 years old, that was coaxed to sprout again. Stories that make time feel soft and expandable, as if life can wait calmly through centuries and still remember how to begin. And as you listen, you might let these images settle like warm blankets over the mind. Quiet plant memory, bamboo rising with gentle speed, rare blooms calling in their pollinators, and seeds resting through long ages, each one a peaceful reminder that on Earth, life not only survives, it patiently prepares. And when the moment is right, it begins again. As you keep drifting through this gentle bedtime story, you can hold the image of a seed resting in the palm of your hand. A small, quiet container of tomorrow, patient and still, carrying the possibility of whole forests while it sleeps. And from that calm sense of waiting, we can wander to tropical shorelines where land and sea meet in warm, brackish water, and mangrove trees stand with tangled roots like slow, careful sculptures. Most plants struggle in salt, yet mangroves have learned a peaceful kind of adaptation, with some species filtering salt at the roots, so mostly fresh water rises into the tree, while others push salt back out through special glands in their leaves, sometimes leaving a faint, crusty sparkle behind. Their arching root systems steady the shoreline, soften the force of waves, and create sheltered nurseries where young fish and crabs can grow in safety. And in that way, mangroves become both engineers and guardians, living borders that protect coasts while thriving in a place where fresh and salt water mix. And from the shore, we can move inland to landscapes shaped by fire. Because, although wildfires can look like pure destruction, many grasslands carry their resilience underground, storing life in sturdy structures such as rhizomes or bulb-like organs tucked beneath the soil. When flames sweep over the surface and the world turns black, these hidden parts often remain protected. And soon, sometimes within weeks, fresh green blades push up again, soft and bright against the ash, feeding grazers and helping the ecosystem rebuild. In some regions, periodic fire is even part of the long rhythm of renewal, clearing old growth and returning nutrients to the soil, so that what looks like an ending becomes, in time, a beginning. And then we drift back to the sea, to coral reefs that feel like underwater cities filled with color and motion, yet are built by tiny animals called coral polyps, small relatives of jellyfish that spend their lives anchored in place, slowly making hard skeletons from calcium carbonate. One polyp is fragile, but together they build structures over thousands of years, layer by layer, quiet work piling up, until reefs become vast habitats that shelter enormous diversity, offering food, hiding places, and breeding grounds for countless creatures, while also calming waves and helping protect coastlines from storms. To move through a reef in your imagination is to move through a cathedral made not of stone, but of life, constructed by innumerable small beings, repeating the same gentle act across deep time. And within those reef neighborhoods, some of the most peaceful examples of cooperation appear, like the bond between clownfish and sea anemones, where a fish that would normally be stung and paralyzed can live safely among waving tentacles. Because its body is coated in a protective mucus, the anemone becomes a living shelter, and in return, the clownfish can help by chasing away certain threats, cleaning away bits of debris, and stirring water around the anemone so it stays healthier. A quiet exchange of protection for care that keeps both partners safer than they would be alone. And nearby, reefs also host cleaning stations, places where small, cleaner fish establish a kind of gentle service in the open water, and larger fish, even predators that might normally be dangerous, arrive and wait with surprising calm as the cleaners pick away parasites, dead skin, and debris. Sometimes the larger fish even hold still with mouths open, so the cleaners can tidy delicate areas like the gills. And both sides benefit. The cleaners gain a steady meal, and their clients feel relief, turning a competitive world into a brief pocket of trust. And as your breathing slows, and this relaxing story continues to guide you toward deep sleep, the next wonder ahead is about sharks and motion itself. Because for some sharks, swimming isn't only travel, it's the steady act that keeps life going, moment after moment, without pause. As you settle even deeper into this nighttime story, you can imagine the ocean as a wide, dark cradle, and within it, certain sharks moving with a steady, unbroken glide. Because unlike fish that can rest and still draw water across their gills, some sharks depend on constant forward motion to keep oxygen-rich water flowing through their gills. These are the sharks whose bodies are designed for ram ventilation, meaning their swimming itself becomes their breathing. And so they continue through the water day and night with a quiet, persistent rhythm, as if stillness is not an option. When it's time to sleep, they don't stop, but instead allow parts of the brain to rest while the body keeps moving, drifting in a half-dream of continuous motion, the ocean serving as both their bed and their endless road. And there is something almost hypnotic about that. An animal built to wander, sustained by momentum, gliding through the dark like a living current. And from that ceaseless swimming, we can float gently to a warm, sandy beach where a very different journey begins. Because newborn sea turtles, just hatched, wriggle free from their nests and make a small, determined crawl toward the sea, guided by instinct toward the brightest horizon, often the moonlight and starlight shining on the waves. Later in life, sea turtles travel far greater distances, crossing wide oceans and somehow returning to the same coastlines where they began, using cues that may include the planet's magnetic field and the guidance of the sky. And it's a peaceful thought that even a faint shimmer can become a map, that tiny points of light can lead a creature through immense darkness. And in colder seas, penguins show another kind of quiet practicality, because fresh water can be scarce where they live. Yet, they can drink seawater and swallow salty prey without harm, thanks to specialized salt filtering glands that remove excess salt from their bodies. The concentrated salt is then released in droplets or fine sprays, sometimes visible when a penguin shakes its head. And this small adaptation frees them to live fully in the ocean world without depending on streams or rainfall. A simple, elegant solution that turns the sea into a usable source rather than a danger. And high above the water, where land might be distant and resting places rare, some birds have found ways to sleep without truly stopping, slipping into brief, repeating moments of rest while still in flight, as if sleep itself becomes flexible enough to travel. In certain long-distance flyers, one half of the brain can rest while the other stays alert enough to keep course, allowing tiny micronaps that add up across long hours. And the image is strangely soothing. An animal carried by invisible air, eyes heavy, mind half dreaming, yet still moving safely through the night. And among the greatest ocean wanderers of the sky are albatrosses, birds shaped for wind, with long wings built to glide for extraordinary stretches of time, using the energy of air currents above waves, rising and dipping in smooth arcs so they can travel great distances with barely a flap. To picture an albatross floating above the sea is to picture effortlessness, a creature letting the wind do the work, as though the sky were a quiet river and the bird a calm boat upon it. And then, in a completely different scale of motion, hummingbirds bring us back to the tiny and the radiant, because to hover and dart the way they do, they burn energy at a tremendous rate, their hearts beating incredibly fast during flight, and their bodies needing frequent nectar to keep that small furnace running. Yet even they have a nighttime answer to the problem of energy, slipping into a state called torpor, where the body slows down dramatically, as if taking a small, protective dive into stillness until morning returns, which feels like a gentle reminder to your own body right now. It's safe to soften, safe to slow, and safe to let sleep take over, little by little, while the world outside continues its quiet motion. As you continue this relaxing story, you can stay with the hush of nighttime and the soft idea of extremes held gently in nature, like the hummingbird, so tiny it seems almost weightless, yet strong enough to cross wide stretches of water in a single, non-stop flight, carrying its bright, jewel-like life on a heartbeat that burns fast, then wisely slows when darkness asks it to rest. And from that tiny powerhouse, we can drift into the world of bird courtship, where survival sometimes becomes beauty. Because in certain species, the search for a partner turns into a careful performance, like birds of paradise that prepare a small stage on the forest floor and then move through precise dances, hopping, swaying, and lifting ornate feathers until their bodies become shifting patterns of color and symmetry, like living mosaics, while watchful females quietly decide which display feels most skillful and alive. Elsewhere, grebes perform their own elegance on water, matching each other side by side with synchronized motions that look like choreography, as if the lake itself were a ballroom. And these rituals feel less like hurried instinct and more like patient art refined over countless generations. A reminder that life can express itself through rhythm as much as through strength. And in the forests of Australia, there is another kind of performer, the lyrebird, famous not only for its striking tail, but for a voice that can echo almost anything it hears, mimicking other birds and natural sounds, and also copying the sharp, unfamiliar noises of human life, camera clicks, engines, even harsh mechanical whines. Then weaving these sounds into long, complex songs meant to impress, so that standing in the woods and hearing a lyrebird can feel like the whole environment is speaking back in a strange, layered chorus. And then, as your breathing grows slower, we can return to long-distance travelers, because the Arctic tern lives as if it is always following light, migrating from Arctic breeding grounds down toward Antarctica and back again each year, tracing vast arcs across the planet. So it experiences more summer than almost any other creature. A small bird living a life shaped by motion, weather, and the wide, open sky. And while birds write their journeys in air, tiny spiders have found a way to travel without wings at all. Because when young spiders need to spread away from crowded beginnings, they climb upward, lift their bodies, and release fine threads of silk that catch the wind, letting them drift and balloon across fields and forests, sometimes rising high into the atmosphere like living seeds carried on invisible currents, occasionally even crossing water and landing far from where they began. It's a quiet, sleep-friendly image, gossamer strands lifting a small traveler into the darkening sky, not fighting the wind, simply letting it carry them. And speaking of silk, orb weaver spiders are among nature's calmest engineers, spinning symmetrical webs that can shimmer with dew in the morning, using different kinds of silk for different purposes. Strong supporting lines, elastic strands that absorb impact, and sticky spirals that hold fast, creating a structure that looks delicate yet can stop insects much larger than the spider itself. People have long been fascinated by spider silk because, for its lightness, it can be remarkably strong and resilient, stretching rather than snapping, and the web's quiet geometry can feel like a gentle reminder that even in small corners of the world, life builds with patience, precision, and a kind of peaceful genius that asks nothing from you now except to listen, relax, and let yourself drift a little further toward deep sleep. As this calming narration continues, you can picture the quiet patience of a spider at work, turning the night into careful architecture, weaving and building with a steadiness that feels almost meditative. And from that gentle image, we can slip beneath the surface of the ground, where trapdoor spiders create homes that are less like webs and more like hidden cottages. They dig a burrow and line it with silk, then shape a camouflaged lid from soil and plant bits, attaching it with a silk hinge so it can swing open and close with almost no sound. From inside, the spider rests in stillness, feeling for the faint tremble of footsteps above. And when prey comes close, the door flips open in a quick motion. The spider grabs what it needs, then retreats again and pulls the door shut so neatly the entrance seems to vanish back into the earth. A secret kept safe from weather and wandering eyes. And while the earth holds these quiet fortresses, the wider insect world contains strategies that can feel eerie in concept, like certain parasitic wasps that place their eggs inside other insects, and as their young develop, release chemicals that alter the host's behavior, nudging it to act in ways that protect the growing larvae, sometimes guiding a victim into a burrow like a subdued puppet, or compelling a host to linger and guard the wasp's developing stage when it would otherwise flee. It is a darker kind of ingenuity, and in a bedtime story, it can be held at a distance, simply as another example that nature is endlessly inventive, shaping behavior as well as bodies, and finding survival routes that are strange to the human imagination. And then, to soften the mood again, we can return to a warmer, more peaceful form of animal communication. Because inside a honeybee hive, information moves through motion rather than words. And when a forager finds a rich patch of flowers, she returns and performs a waggle dance, a looping, rhythmic pattern that encodes direction and distance in relation to the sun. Other bees watch and interpret, then leave the hive and fly with surprising accuracy toward the food source. And the dance can shift as the sun moves, keeping the message aligned with the changing sky. So the whole colony functions like a gentle shared mind built from thousands of small decisions. It's calming to imagine that bees tracing small figure eights in the dim hive light, sisters reading the vibrations, and the world outside quietly filling with purposeful flight. And from insects to amphibians, some frogs show a kind of devoted care that feels tender, because in parts of Central and South American rainforests, certain frog parents guide their young in careful steps. One well-known example is a small poison dart frog species, where the father carries newly hatched tadpoles on his back, climbing from the forest floor up stems and leaves, placing each tadpole into a tiny water pocket high in a plant. Like a a miniature nursery sheltered from many dangers. In some species, the mother returns to feed the growing tadpoles with unfertilized eggs, a steady offering that helps them survive where food is scarce. And the whole process feels like quiet guardianship, repeated again and again through the wet green world. And then there is a birth story so unusual it can sound almost unreal, the Suriname toad, where after mating, the female's back becomes a kind of living cradle, and the fertilized eggs are pressed into her skin, which swells and forms small chambers around them, turning her back into a sheltered nursery. Later, when development is complete, tiny toads emerge from those pockets, already formed, leaving the mother to return to her normal life after carrying that hidden burden. A method that may seem unsettling to human eyes, but functions as protection in a world full of predators. And now, as the forest air cools in our imagination and the night grows deeper, we come to one more gentle wonder waiting on a leaf in the cloud forests, the glass frog, small and green, resting so quietly that only when you look closely do you notice something extraordinary about its body. As we continue this gentle nighttime story, imagine yourself in a quiet cloud forest where the air feels cool and damp, and a small green frog rests on the underside of a leaf, so still it seems like part of the plant, until you notice something softly astonishing. In many glass frog species, the skin and muscles can be translucent, and the belly may look almost see-through, offering a delicate glimpse of a tiny heart beating and inner shapes resting in gentle motion. This unusual transparency may help the frog stay safe by blending with the broken, dappled light that filters through leaves. So when it clings beneath foliage, it can fade into the green background like a living shadow, fragile in appearance, yet perfectly suited to its hidden life, as though nature created a small window that remains protected by nothing more than a thin veil of living tissue. And from that quiet, otherworldly beauty, we can drift into the dry deserts of North America, where a different kind of defense appears in the horned lizard, a spiky little reptile that relies on camouflage and stillness, but also holds an astonishing last resort. When threatened, it can increase pressure around the eyes and release small jets of blood from the corners, sending a surprising spray that can taste unpleasant to predators and discourage them from continuing. It's not a graceful trick, and it may leave the lizard briefly unsettled, yet it can be effective, a reminder that nature's solutions are not always elegant, only practical, written into survival like a strange footnote in the desert sands. And then, as if to soften the mind again with a hint of wonder, we can return to water and the illusion of walking upon it. Because in Central American forests, the basilisk lizard can sprint across the surface of ponds and streams for several meters, using powerful hind legs to slap the water fast enough to create small air pockets and momentary support, skimming forward before finally diving in. Younger basilisks, being lighter, can often travel farther, but even adults can dash across water when they need to escape. And in the shimmering light of a jungle river, it can look like myth briefly turning real. Yet, it's simply physics used well, repeated in a heartbeat of motion. And if that feels like a dream, the canopy holds another one, because some snakes can glide through the air, with certain tree snakes launching from branches and flattening their bodies by spreading their ribs, shaping themselves into a living surface that catches air, while gentle undulations help them steer. Without wings, they can still travel impressive distances from tree to tree, moving like a ribbon through open space. And watching such a creature in your imagination can feel oddly calming, proof that the world contains more possibilities than the mind expects. And then, from graceful gliding to ancient weight, we meet the Komodo dragon, the largest living lizard, moving with slow, deliberate confidence, built for patience and sudden power. And its bite is more than a set of sharp teeth, because it can also deliver venom that helps weaken prey by disrupting normal blood pressure and clotting, making an escape increasingly difficult over time. The Komodo's method is quiet and persistent. An ambush, a bite, and then a steady following of scent, like an old predator, using time as part of its strategy, carrying echoes of a more primal world in its heavy steps. And finally, to end this part on a slower, sleepier rhythm, we can think of crocodiles, animals that embody stillness and endurance, able to go long periods without food because their metabolisms are slow and their bodies conserve energy with remarkable control, including the ability to reduce their heart rate dramatically while they rest motionless in water or mud. This lets them wait with extraordinary patience and survive lean stretches when meals are rare. And as you listen, you can let that same permission seep into your own body now. The permission to be still, to conserve, to soften, and to drift further into deep sleep, while the world outside continues in its quiet, steady way. As you rest in the quiet, it can feel comforting to remember that crocodiles are like living echoes of deep time, their bodies shaped by an ancient lineage and refined across ages, and their slow, steady hearts seem to keep a rhythm that favors patience over hurry, reminding us that survival is not always about speed, but about efficiency, stillness, and the calm ability to wait. And from that ancient stillness, we can drift into dark, cloudy waters where seeing is difficult. Yet some fish have found another way to sense the world, creating a gentle language made of electricity, because species like knifefish and elephant nose fish generate weak electric fields around their bodies, and then subtly change those signals to navigate, detect objects, and communicate, each individual carrying a slightly different electrical signature, so others can recognize a neighbor, a rival, or a potential mate. It's a soothing thought to imagine a river filled with silent electric conversation, pulses and waves passing through water like soft messages that never need sound. And among the most famous of these living electrical animals is the electric eel, which isn't a true eel at all, but a kind of knifefish. And it can produce strong discharges that may reach around 600 volts, used to stun prey or defend itself, while also producing gentler pulses for sensing its surroundings. Its body packed with specialized cells that act like a biological battery, stacked so that when they fire together, they release a sudden jolt. To picture that is to picture lightning turned into biology, wild energy controlled by a living nervous system, powerful yet purposeful. A reminder that nature can build technology in flesh and blood long before humans ever did. And if electricity feels like one hidden language of water, light can become another, especially in the ocean's twilight where darkness dominates. Because many deep-sea fish don't glow alone, but instead host bioluminescent bacteria in special organs, offering the microbes a safe home and steady nutrients, while receiving a continuous living lamp in return. Some fish use that glow to blend with faint downwelling light, so predators below can't see their silhouette, while others use it as a lure, drawing curious prey closer. And some, like flashlight fish, can even blink their glowing patches on and off, turning the darkness into a place where patterns can be signaled gently, like quiet Morse code beneath the waves. And then, moving from bacterial lanterns to animals that paint with their own skin, squid bring us back to the idea of communication through shifting patterns. Because their bodies contain chromatophores, tiny color cells that expand and contract quickly, letting them flash stripes, ripples, and spots across their skin in moments, changing from pale tones to deep colors, as though emotions were written on the surface. Many species appear to use these rapid displays not only for camouflage, but also as signals to other squid, coordinating patterns in groups like a slow, underwater light show, a conversation spoken in color instead of sound. And finally, in the deepest, most breathless parts of the sea, where oxygen is so scarce that many creatures struggle to function, the vampire squid lives with quiet restraint, drifting through nearly oxygen-free layers by conserving energy. Its body soft and gelatinous, its arms connected by a cloak-like web that makes it look dramatic, even when it is simply floating rather than chasing prey. It gathers marine snow, tiny drifting particles of organic matter, using sticky filaments to collect them, and roll them into small meals, surviving not through speed or aggression, but through efficiency and patience, like a gentle scavenger in a world that offers very little. And as you listen to this calming narration and feel sleep growing heavier, these ocean facts can settle like a soft tide in the mind, electric whispers in muddy rivers, living lanterns in the deep, color messages flashing across squid skin, and a quiet vampire squid drifting peacefully through thin water, all reminding you that life adapts not by forcing the world to change, but by learning, slowly and calmly, how to live within it. As you rest with this sleep story and let the pace stay slow, we can drift back down into the Antarctic depths, where the water is heavy with cold and the light fades into near nothing. And there, in a world that is mostly hidden from human eyes, lives the colossal squid, rarely seen, scarcely understood, yet imagined as a true heavyweight of the sea, with a body that can rival the length of the giant squid, while carrying even more mass, like a deep ocean leviathan, moving quietly through the black. One of its most striking features is its eyes, enormous by any standard, reported at up to around 30 centimeters across, built to gather the faintest traces of glow in the abyss, whether it's the soft shimmer of bioluminescent life or the dim suggestion of a large predator passing nearby. And just picturing such an eye is like picturing the deep ocean itself, looking back, wide and watchful, shaped by darkness, so complete that vision must become vast. And in that same silent zone, another creature appears almost like a living science fiction design. The barrel-eye fish, drifting with a calm stillness, its head forming a transparent dome so you can see its eyes within, glowing softly and angled upward, as if it spends its life scanning the dim silhouettes above while it hovers. With minimal effort, those eyes can rotate forward when needed, and the clear shield of its head helps protect them from stinging, drifting animals in the water column, turning what seems like vulnerability into a clever kind of armor. A reminder that in the deep sea, even a skull can become a window when evolution decides it should. And then there is the anglerfish, an icon of the abyss, whose very survival depends on turning light into a trap, carrying a small glowing lure on a stalk above its mouth, often lit by tiny bacteria that live in partnership with it, so that in perpetual night, the lure becomes a floating point of hope that curious prey swims toward without understanding. When the moment comes, the anglerfish closes its jaws with sudden speed, swallowing prey that can seem surprisingly large for its body. And the species' life history can be just as strange, with tiny males in some kinds of anglerfish attaching to much larger females for the long term, becoming a permanent source of sperm in a world where finding a mate can be as difficult as finding a star in a moonless sky. And as we let that eerie wonder soften again into something more gentle, we can return to reef shallows where camouflage becomes creativity. Because decorator crabs sometimes collect bits of their environment, small sponges, pieces of coral, and even living anemones, and attach them to hooked bristles on their shells, turning themselves into moving patches of reef. The choices can be practical as well as beautiful, since certain sponges can be unpleasant or toxic to predators, and anemones can sting would-be attackers, while the crab, in return, gives its living decoration a ride to new places. So what looks whimsical is actually a calm collaboration that helps both survive and nearby. Another kind of cooperation plays out among hermit crabs, who don't make their own shells, but must borrow empty snail shells and trade up as they grow. And when a larger shell becomes available, groups may gather and form a line from smallest to largest, each waiting for the crab ahead to move into a better home, so the next can take the shell just vacated, like an orderly chain of moving day where patience and timing turn scarcity into a shared solution. And now, with your mind growing heavier and your breathing staying slow, we arrive at another ocean marvel waiting just ahead. The mantis shrimp, a small, vivid predator whose eyes can perceive far more kinds of color information than human eyes do, as if it lives in a richer rainbow than we can easily imagine. As you continue to relax into this bedtime story, imagine the reef growing quiet in the late hours, the water darkening to a deep, velvety blue, and somewhere among the corals, a mantis shrimp moving with private certainty, perceiving a version of the world we can't truly picture, because its eyes can detect signals beyond ordinary human sight, including ultraviolet and patterns of polarized light, so the reef may appear to it like a layered tapestry of hidden markings and secret glows, useful for finding food and for sending messages to its own kind. It's a soothing thought that reality has many additions, and that our human vision is only one gentle slice of what exists. while the ocean holds colors and cues that will always remain just out of reach. And beyond that extraordinary way of seeing, the mantis shrimp carries another surprise: an ability to strike with astonishing speed, using a club-like limb that snaps forward so fast it can create cavitation bubbles, tiny pockets that collapse in sharp bursts, adding extra impact so the blow can crack shells and stun prey with a force that seems impossible for such a small creature. Even more strangely, it can repeat these strikes without breaking itself, because its body stores and releases energy through spring-like structures and shock-absorbing tissues, turning raw physics into a precise hunting tool, and then letting that intensity soften into something more delicate. We can drift into the ocean's twilight, where some worms glow with a gentle green bioluminescence, thin, fragile bodies that shimmer like underwater fireflies, sometimes releasing tiny glowing particles when disturbed, so the water briefly fills with soft emerald streaks, as if the sea were writing quiet calligraphy in light. Whatever the purpose, confusing predators or attracting a mate, the effect is calming to imagine. A small breath of living glow that doesn't shout, but simply appears and fades. And far below, where the seafloor cracks and the planet's inner heat meets the cold sea, hydrothermal vents build their own strange architecture, because mineral-rich hot water pours out, and as it meets colder water, metals precipitate and form jagged chimneys that rise like towers, some sending dark plumes upward like drifting smoke. These structures are not empty stone, but the base of entire communities, with animals gathering around bacteria that harvest chemical energy. So, in a world without sunlight, chemistry becomes the lamp, and the chimneys become life's skyscrapers. An underwater city powered by the earth itself, and from those deep, heated places, we can rise to volcanic regions on land where hot springs steam and bubble. Waters so hot they seem inhospitable, yet certain organisms, thermophiles, live comfortably there, with enzymes and cells adapted to keep working where most life would fail, sometimes even painting the pools in vivid colors that come from living pigments. And if heat feels extreme, acidity can be extreme too, because there are places on Earth where lakes and pools become intensely acidic, environments that look like they should dissolve life away. Yet specialized microbes still persist, with membranes and internal chemistry built to resist the harshness, sometimes turning the landscape strange shades of red, orange, and yellow, as if the ground were dyed. And as you listen, letting these images pass slowly through the mind, you might feel the gentle, repeating message underneath all of them. Life is endlessly adaptive, finding a way to glow in darkness, to build cities from minerals, to endure heat and acid, to see hidden colors, and to keep going quietly. So you can also let yourself keep going in the simplest way tonight, by resting, releasing the day, and drifting further toward deep sleep. As you rest with this calm bedtime story, you can let the idea of extreme places feel less harsh and more quietly fascinating. Because when microbes manage to live in acidic lakes on Earth, it gently stretches the imagination toward other worlds too, suggesting that if life can adapt to strong chemistry here, then perhaps somewhere far away, it could also find a way to persist, not loudly, but stubbornly, patiently, refusing to disappear. And beneath that thought is another soothing one. Earth is not only alive on its surface, but also deep below it. Because under our feet, there is a hidden biosphere in cracks and pores within rock, where bacteria can live under immense pressure, separated from sunlight and the surface for incredibly long spans of time, surviving on simple chemical energy such as hydrogen released from water reacting with rock, or on traces of methane, sulfur compounds, and other subtle fuels. Some of these deep-living communities move through life at a pace that feels almost dreamlike to us, with energy so limited and conditions so steady that their processes can unfold on timescales that make our busy human days feel very fast. And it's humbling to imagine such a vast, invisible realm quietly pulsing inside the planet, so hidden and yet so real. And then, returning to the seafloor where heat meets cold, we can picture hydrothermal vents again, those places where scalding mineral-rich water pours out into darkness and creates an entire world without sun, where giant tube-worms, clams, crabs, and other creatures gather around bacterial partners that turn chemicals into usable energy through chemosynthesis. Inside tubeworms, symbiotic bacteria can use hydrogen sulfide, dangerous to many forms of life, as a fuel source, effectively feeding their host from within. So the worm becomes a living home for a chemical kitchen, and the whole vent community thrives in a place that seems, at first glance, too hot, too toxic, too black to support anything at all. And from vents to boiling pools, to ice, to crushing depths, to radiation, to harsh acids and alkaline waters, the pattern repeats across Earth. Wherever humans once assumed life could not exist, some form of it has been found, and we call these survivors extremophiles, a broad family of organisms that show how wide the boundaries of life can be. Some endure radiation that would quickly harm us. Others tolerate being dried out almost completely, and then reviving when water returns. And together, they quietly reshape how the mind pictures habitable, turning it from a narrow rule into a wide possibility, which also changes how people imagine places like Mars, or the icy moons of the outer solar system, worlds that might seem empty yet could still hold hidden life if conditions allow. And now, as the night deepens and your attention softens, we can lift our gaze from microbes to the animals you see every day, because birds are not just descendants of dinosaurs in a vague sense. They are the living continuation of that lineage, shaped from theropod ancestors over vast time, with feathers that likely began serving purposes like insulation or display long before true flight, and then gradually became part of gliding and soaring. So every bird perched on a branch is, in a quiet way, a small piece of deep prehistory, still moving through the modern sky. And if birds are one branch of that ancient story that transformed and diversified, crocodiles are another that endured, holding onto a body plan so effective that it has remained recognizably similar across immense spans of time, carrying armor, powerful jaws, and a patient ambush style that works well in rivers, swamps, and coasts. And their survival has always leaned on efficiency, the ability to slow down, to wait, to go without food for long stretches, to let time pass without panic, and finally, As this relaxing story continues to guide you toward deep sleep, we can drift toward the next gentle wonder. Fish that blur the line between water breathing and air breathing, carrying lungs as well as gills, as if nature kept more than one option ready for times when the world changes. As you rest with this relaxing story and let your thoughts move slowly, we can return to the gentle idea of animals that bridge worlds. Because while most fish rely only on gills, some species carry a second option as well, lungs, allowing them to breathe air when water becomes warm, shallow, or scarce. Lungfish are a beautiful example of this, rising to the surface to gulp air and using their primitive lungs to survive conditions that would end many other fish. And in parts of Africa and South America, they can even endure drought by burrowing into mud and forming a protective cocoon, breathing softly until rain returns and water fills the world again. This double breathing way of life feels like a quiet relic of deep history, a hint of the long transition from water to land. And when you imagine a fish surfacing to take air, it can feel like a small window into our own distant origins, because it was ancient fish like these that eventually gave rise to amphibians, reptiles, and much later, mammals. And then, staying with the theme of transformation across time, it can be soothing to remember that whales, the largest ocean animals, come from ancestors that once walked on land, because over millions of years, certain land mammals gradually adapted to spending more and more of their lives in water, their bodies reshaping into forms suited for swimming, their limbs changing into flippers, their tails becoming powerful, and their nostrils shifting upward into blowholes, until the ocean became their full-time home. When a whale rises to breathe or breaks the surface in a slow, heavy motion, you're seeing not only a sea giant, but also a lineage that returned to the water after a long journey, carrying the memory of land in every breath it takes. And in another corner of Earth's past, horses tell their own slow story of change, because the ancestors of modern horses were once much smaller, closer to the size of a small dog, living in forested environments with multiple toes and a browsing diet. And as climates shifted and open plains became more common, their bodies changed with the landscape, growing larger, lengthening legs, moving toward a single strong hoof for speed, and developing teeth and digestion better suited for tougher grasses. It's a calm reminder that evolution is like a long, patient conversation between life and environment, with bodies slowly adjusting as the world reshapes itself. And then, with the night deepening, we can gently rest in the presence of the blue whale, the largest animal known to have ever lived, a true living monument of biology, enormous in length and weight, yet feeding primarily on tiny krill in vast mouthfuls, moving through the sea with a kind of slow grace that doesn't match its size. Its calls are low and far-reaching, traveling across long distances underwater. And simply imagining a blue whale moving in the dark ocean can make the mind feel small in a peaceful way, as if worries shrink when placed beside something so vast and calm. And not all survival stories are about becoming bigger or changing dramatically, because some insect lineages have stayed remarkably stable over immense spans of time, with forms like cockroaches and silverfish resembling ancient relatives, and dragonflies carrying a design so effective it has endured, even though prehistoric versions could be far larger than the ones seen today. Their persistence suggests that evolution isn't always a constant reinvention. Sometimes a body plan works so well that it changes only slightly while ages pass around it. And through all these long chapters, Earth itself has lived through repeated moments of immense loss, with several major mass extinctions reshaping the web of life. Yet each time, life returned and diversified again, slowly rebuilding new ecosystems from what remained, which can feel like a quiet reassurance as you listen. The living world has always carried both endings and beginnings. And tonight, in your own small way, you can choose the gentlest beginning of all, closing your eyes, loosening your thoughts, and letting yourself drift toward deep sleep. As you keep resting with this gentle nighttime story, you can let the thought of Earth's deep history move past you like slow clouds. Because over immense spans of time, there have been moments when life was reduced dramatically, whole ecosystems emptied, and familiar kinds of creatures vanished. And yet again and again, the living world returned, filling the open space with new forms, new experiments, and new strange beauty, so that even after great loss, evolution continued reshaping, renewing, and quietly proving how tenacious life can be. And if that sounds heavy, it can also be held softly, like a calm reminder that existence is both delicate and persistent at once. Not a single fragile flame, but something that can dim and then rekindle, finding a way forward into new eras. And far to the south, where Antarctica now feels like a frozen silence, it can be soothing to picture that it was not always this way, because millions of years ago it held forests, and traces of that greener past still linger in preserved plant material, seeds, spores, fragments kept in cold ground like a library of lost landscapes, with bits of genetic information remaining as a quiet record of what once grew where ice now rules. To imagine holding such a remnant is to imagine holding time itself, a small piece of a world that changed slowly until green became glacier, and the story of ancient traces continues inside the human body too, because within our DNA are fragments left behind by very old viral infections, genetic echoes from long ago that no longer behave like viruses, yet still remain as part of the genome, with some even repurposed over evolutionary time to support important functions in mammalian life. A gentle reminder that nature can turn even past invasions into unexpected tools, weaving old adversity into new survival. And as you breathe in and out right now, you can let your breath become part of the story as well, because the air you take in is made of atoms that have been traveling and recycling for ages, moving through oceans, soil, leaves, and bodies, so that with every slow inhale and exhale, you participate in the quiet circulation of matter that connects the living world across time. As if breathing is not only survival, but also a soft kind of belonging. And underneath all this variety, there is a calming unity, because every living thing on Earth, microbes, plants, insects, fish, birds, and people, uses the same basic genetic language, the same shared alphabet of life. which hints at a common origin long ago. One ancient beginning that branched outward into all the different shapes and stories we see today, making the living world feel less like separate islands and more like one family tree spreading in countless directions. And finally, if you let your mind widen just a little, you can remember that the atoms in your body have an even older history than Earth itself, because elements like carbon, oxygen, iron, and calcium were forged inside stars and scattered through space when those stars ended. And over time, those star-made materials became planets, oceans, and eventually living cells. So in a very real sense, you are made of ancient stardust, cosmic matter, arranged into a human life that is now safe to rest, safe to soften, safe to drift toward deep sleep. As the universe continues its quiet turning, as you rest beneath the quiet sky, you can hold a gentle thought in your mind. The universe, in its own slow way, shaped itself into matter, and that matter became the atoms that now make up you. So when you glance toward the night, you are not only looking at distant stars, you are also looking at something strangely familiar, ancient relatives scattered across darkness, shining softly in their faraway places. And now, dear listener, our soothing journey through the most relaxing facts about life on Earth is coming to a peaceful close, as we've drifted together through forests and oceans, across deserts and hidden depths, moving from tiny, resilient lives to immense, singing giants, and noticing again and again how life adapts, endures, and quietly remakes itself with patient creativity. If your eyelids are heavy, you can let them close without effort, letting this bedtime story dissolve into comfort and allowing your breathing to become slow and steady, like a calm shore receiving gentle waves, like soft wings passing through cool air, like tides moving in the dark without anyone needing to hurry. Each breath can feel like a small thread connecting you to the long living story of this planet, a shared web that stretches back through time, linking you to oceans, forests, creatures seen and unseen, and the deep history carried inside every cell. If you enjoyed this relaxing story and these nighttime story facts, you can always return to Sleepy Story Facts whenever you want help to fall asleep or sink into deep sleep. And if you feel like it when you wake another day, you may choose to support the channel in a quiet way. But for now, there is nothing more to do at all. Simply rest, feeling yourself held by the same world that holds mangroves and mountains, reefs and rain, by the same earth that turns steadily through night. And let the thought cradle you gently. You belong here. You are part of this ancient rhythm, and you carry the memory of oceans and starlight within you. So sleep well, dream softly, and drift onward into silence. Good night.